All right, I gotta change the camera. Hey guys, we're gonna get started here in just a sec. All right, give me just a second to get this up. Thank you for joining. We'll be ready to get this going in just a moment. All right, my friends. Glad to see so many of you on tonight to get this review. So let's go ahead and get started. Where my other 1.14K, I know, right? All right. So let's go ahead and get this started. I'm going to share my screen. I need somebody to type in the chat. Let me know if you see it just to make sure. Let's see. All right. Please tap in there. You should see review for topic 8 summative. Excellent. All right. You guys can hear me okay, I suppose? Good. All right. Yeah. Excellent. All right. So we're going to do this just like we do in class. We're going to do it just like we do in class. Here we go. Don't mind my cat mewing in the background. All right. Okay. So we're going to go ahead and get started. If I can here. Come on. You know how Jeff is. He's getting a little antsy here. He doesn't want to write. Wonder why that's doing that. Yeah, my camera on the laptop's weird. It's giving me the back camera, I guess, but it's not doing the front, and I can't seem how to switch it here. It's kind of weird. That's odd. I know. Come on, Jeff. I know he's being weird. All right, so you can see me move my mouse. You just can't see Jeff. What is up with that? Huh. That's super strange. All right. Well, guess what? We're going to try this just as it is. And we'll just see how it goes. We're going to learn together. It's going to be okay. All right. Here we go. So we're going to start things off with my favorite thing of all, Pythagorean theorem, right? So here we go. So we have a squared plus b squared equals c squared. All right. So we have two sides already. These are our legs. We have this leg we're going to call A. We have this leg we'll call B. And they're legs because they make that little L. See the L of the right angle. And then we have C, which is the hypotenuse. So that's always the longest side. It's always the slanty one, and it is diagonally across from the right angle. So what we're going to do is we're going to take A squared. So it's going to be 9 squared plus B squared, which is 40. So 40 squared. Wow, this is really ugly writing right now. And we have C squared. So what we're going to do is we're going to add these together. So 9 squared is 81. And 40 squared is 1,600. And that's going to equal C squared. And I'm running out of space here. So I'm going to move over to the other side. If I add that together, we get 1,681, which is equal to C squared. So I'm going to pull up my calculator because I don't know what the square root of that is. Come on. All right. I guess it pulled it up 3 times. You guys still seeing and hearing everything okay? I'm trying to go between windows here. Yeah, the camera is kind of cooked. Pull up the calculator. All right. You like to do this the other way? Yeah, that's fine. All right. So the calculator, we're going to go 1,681 divided by, oh, not divided, sorry, square root. Clear. 1,681. And we're going to square root it, which gives us 41. So we end up with, so once we square root this here, oh my. So we're going to square root both sides. So that's going to leave us with C. And C is 41. So this side over here that we're missing is 41. Better? Yes, no? Is it any better, guys? We getting there? Yeah, let's go. Okay. And guess what? Jeff's working now too. Even better. Let's go. Okay. I wish I could hide that camera. Okay, here we go, guys. Let's do this. I'm ready now. We are rocking and rolling. Okay. Whew. All right, question 3. All right, the kite is flying 10 feet off the ground. Its line is pulled taut. Remember this word taut? Remember what that means? It means it's tight, right? So it's not loose and hanging there. It's tight string. And it casts an 8-foot shadow. And we need to find the length of that line. Now, this is just a word problem, but it's the exact same process. You've got 2 legs. Remember, they make up the L of that right angle. And this time we're rounding to the nearest tenth. So it's still going to be a squared plus b squared equals c squared, right? Okay. So we have a and b. So we have 8 squared plus 10 squared equals c squared. So I know that 8 squared is 64. I know that 10 squared is 100. And then we got c squared. If I add those together, I get 164, which equals c squared. And then when I square root, I end up with c. And then on my calculator, I go 164 and square root it. And I get 12.8. They want the nearest hundredth, right? 100th? 10th. So 12.8 we're using. So 12.8. That is the length of that string. Is that all right? I'm trying to watch the comments as I go. Yeah, 2 is exactly the same as 1. You want me to go back to 2? I can go back and at least show you the screen and explain it. Yeah, we did 2, but you missed it from the other thing. I'll go back. No worries. All right, so this is question 2. So we had a squared plus b squared equals c squared. And again, we had the 2 lengths, the two legs, I should say, that were on the right angle. So 20 squared plus 21 squared equals c squared. And we squared the 20 and the 21, added them together to get 841. Then you square root 841, and you end up with c, which is 29. Okay? Does that help? All right, we all good? Yeah, my cat is very mouthy. You're right. She wants to go outside. Okay. Good. Okay. So let's go ahead and go to number 4. Where were we at? 4? Yeah. All right. All right. So a lot of people asked me questions about this one today. So let's get to number 4. This time they gave us 3 lengths, and they want us to determine if it can be side lengths of a triangle. So remember with this, there's 2 types of questions like this. Sometimes they'll ask you about whether or not it can be a triangle, just any kind of triangle, or if it's a right triangle. Remember, when they're asking about a right triangle, that means we have to put it in the Pythagorean theorem. The same thing we just did those first 3 problems. A squared plus b squared equals c squared. Triangles. So how do we determine if it's a triangle at all? Well, it's a plus b greater than c. A plus b must be greater than c. So you take the 2 smallest lengths, add them together, and they have to be greater than c. So we take this first one, we've got 5, 3, and 5. So the smallest lengths are 3 and 5, and the largest length is 5. So 3 plus 5 is 8. 8 is greater than 5, so that is a triangle. Does that make sense? Then we take the next one, got it the 2 smallest legs. So we got 7 plus 11 should be greater than 18. But 7 plus 11 is 18, and 18 can't be greater than 18, so that is not a triangle. It is not a triangle because it has to be greater than. That's the big one. They're always going to throw one like this at you because they think that you're going to go, oh, well, it equals 18. That's got to be it. But it's not, I promise. All right, now we got the next one, number 3 on here. You got 9, 11, and 15. So we got 9 plus 11. It has to be greater than 15. And I think it's pretty easy to see that that is greater. So that is a triangle. And then this last one, of course, they give you decimals. Ugh, nobody likes decimals. But you can do it pretty easy by putting it in a calculator, and that's perfectly fine. They always like to mess with you on these 2. So we got the 2 smallest. You got 9.7 plus 12.7. And it has to be greater than 21.9. Okay? 9 plus 12 we know is 21. And then 0.7 and 0.7, that's going to be 22.4. That is greater, so this is a triangle. All right? Does that make sense? How we doing? We doing okay? Mm-hmm. What if it equals the same number? Yeah, so if it equals the same, then it's not a triangle. Yeah. A and B have to be greater than C. What's that, Tyler? Not Math Man? What? It's weird. Catman. What? All right. Let's continue. Let's get to number 5 here. All right. So number 5, we're now doing the same thing I just told you a second ago. We're determining whether or not a triangle, so we're saying that these are triangles, are these going to be a right triangle or not? Okay, now this is going to take a lot of work. I won't be able to show all of it on this one screen, but I will show you a couple of them, and then I'll have to do the rest in the calculator, and we'll just have to go through it. Now, I'm going to tell you, I don't know why Alex does this, but it will never be this. It will never, ever, ever be not enough information. Because if you have 3 lengths, you can always find out if it's a right triangle or not. You put it in the Pythagorean theorem. It'll never be not enough information unless they only give you 2 lengths or you put an X or something in there. But if they give you 3 side lengths, you can always find out. So remember, this is always going to be the Pythagorean theorem. That's the big theme of this whole topic, guys. A squared plus b squared equals c squared. All right? So what you're going to do is you're going to do, I'll do the first one here. So 5 squared plus 10 squared equals 11 squared. And we have to make sure that's true. Now, I know that 11 squared is 121. And then 5 squared is 25. And 10 squared is 100. You can be able to tell right away that's not going to be equal. So that is not a right triangle. And that's what we have to do with this. Okay? That's how all these ones go. For B, so this was A. So for B, we have 3 squared plus 9 squared equals 10 squared. Well, I know that 10 squared is 100, so what we need is 100. 9 squared is 81. 3 squared is 9. Does 9 plus 81 equal 100? Nope. Not a right triangle. Okay? Then we got C. I guess I did have room. So we got 13 squared plus 20 squared equals 26 squared. Now, I don't know 26 squared off the top of my head. I know a lot, but I don't know that one. 26 squared is 676. Whoa. And so I know 13 squared is 169. I know that 20 squared is 400. So again, I can kind of just look at this without even adding it, and I can know that's going to be 500 something. That is not a right triangle. Oh, I think it was 3 that were not. That's kind of crazy. And then we got D, the last one. So for this one, 12 squared plus 25 squared equals 37 squared. Can you guys see that? Do I need to clear this up a little bit? There we go. All right. So again, I don't know what 37 squared is. I'm going to use my calculator. And you're welcome to do that. Whew, that's a big one. So this is going to be 1,369. 12 squared is 144. 25 squared would be, thought I knew that one. I think I do, but yeah, that's what I thought. 625. Oh, that's 35? Oh, no wonder. 1,225. Now, if I add those together, I get 1,369, so that is a right triangle. Okay. Now, don't think that you're only going to find one. You might find 2 or 3, or maybe even all 4. Or they might all not be a right triangle. Don't just assume based on that you have 1 or only 2 or whatever. Is that going okay, guys? Everybody good? Do I still have people in here? Got 8 people in here. Okay. Everybody good with that? Drop me a thumbs up in the chat or something if you're good. Okay. All right. Good deal. Okay. Yes, it's going to be in this quarter. Thumbs up. Okay. All right. Good deal. Okay. Let's go ahead and move on to number 6. All right. We're going to find the distance between the points A and B given below. So what we're going to do here is we're going to go ahead and still do Pythagorean theorem one more time. Now, the thing is here, we're going to draw a line. In fact, I'm going to use my highlighter so I can make it a little bit easier to see. All right. We're going to draw a triangle. Let me pick a different color. Can I see? I can't see. Let's do it like this. There we go. That's better. Okay. We're going to make it a nice triangle. Okay. Because if we can find the sides, and it tells us that each square is 1 unit, if we can find the sides, we can find the hypotenuse. So this is going to be 1, 2, 3, 4 on this side. And over here, we have 1, 2, 3, 4 also. So our 2 smallest sides, we're going to go, again, a squared plus b squared equals c squared. So we have 4 squared plus 4 squared equals c squared. Each of those 4 squared is 16. And we add them together, we get 32. And they want us to round to the nearest hundredth this time. So we're going to go ahead and square root this. And what I see, which you guys can't see because I did it on a different calculator, is I have C equal to 5.6568, blah, 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 right? So we want the hundredths place. I always show this, right? We need 2 decimals because that's the hundredths place. So we always look at this one right here to determine what we do with our number. All right. So remember the deal, right? If it's 5 or more, we raise the score. 4 or less, let it rest. Meaning we just get rid of it. Since that's a 5 or more, this 65 is going to become 66. So my answer will be 5.66. Okay? That all good? Good. All right. Do I still have 8 people watching, or is that just 8 was total watching at one point? I don't know. Let's see. Harad, Ellie, and Tyler. Oh, and Ethan. Ethan's in there too. Okay. All right. We're going to move on to the next one. Number 7. All right. This is where we get into all the angles. Okay. So I'm going to do a little different thing here that I started doing today for a couple of you that were struggling still. All right. We have these 2 words we talked about, complement and supplement. Remember that complement means that the angles are going to add up to 90 degrees. And the supplement means the angles are going to add up to 180 degrees. Okay? The way I did this was C comes before S in the alphabet. So that's the lesser number. And then S comes after, and it's a little bit bigger, 180. All right? So let's do these. If we know one angle, and we want to know its complement, all we have to do is subtract it from the total. So for there, we're going to go 90 minus 39, and that's going to give us 51 degrees. Okay? For the angle measure 82, it's one part of a supplementary angle. So we take the 180, and we subtract 82, and that should give me 98 degrees. All right, is that okay? Oh, and Alexis, yep. Let's see. Which one are you confused on? On number 7? I don't know how much delay is on this thing. Okay. All right, let's go ahead and continue. All right, let's go to number 8. This is where it starts to get tricky. All right, we have these complementary angles, and we know they're complementary because they have this right angle here. Okay, and the 2 angles, angle 1 and angle 2, let's just write that here. So angle 1 plus angle 2 is equal to 90 degrees. We know that. And they're giving us what angle 1 and angle 2 are. They're just being cryptic about this. They're being extra for no reason, right? So what we have to do is we have to add these things together and put it equal to 90. So we're going to go with 3x plus x plus 46, right? And that's all equal to 90 degrees, okay? Now, the thing about this is we need to just solve this for x, and that's going to help us find our angles because we can put x back into the place for these angles. So we're combining like terms. So we're going to find the terms that look alike and add them together. So we got 3x here, 1x here. That makes 4x total, right? Then we have 46 that there's nothing else to add with it, and that equals up to our 90 degrees. All right. Then we're going to minus 46 from both sides because we're solving for x here. It's a good reminder for the things that we need to know from earlier in the year as well. So then we have 4x, which is equal to 44. Yep, 44. Then we divide by 4 to get x completely by itself. And x equals 11 in this case. Now remember, this is not our answer. We need to find out what these angles are. So angle 1 is x plus 46. So for angle 1, all we're going to do is say 11 plus 46, and that angle is going to be 57 degrees. And it makes sense to be that much bigger than the other one because it's a bigger angle on the picture. That's not always the case, but this time it is. And then for angle 2, it's 3 times x. So 3 times x, which is 11. And 3 times 11 is 33. So angle 2 is 33. And if you notice, these two, when you add them together, will give you 90. So you know you did it right, and we're good to go. How does that feel? Is that okay? Hi. We all good? If any of you guys jumped in late, you can always go back and watch this live. It'll be on the channel. All right. Okay. Yep. Go ahead, Ellie. But you're good now? Does that make it a little easier? It's hard to see who's talking when and how old this is. Oh, give you a second to write down. Yeah, absolutely. You're good. Oh, I don't know if my camera blocked that x equaling 11, but that's what that is. All right. I'm going to go ahead and move forward. Remember, this is going to be recorded, so you can always go back and look at it later. All right. Number 9, this is where we get into all the other types of angles. All right. What they're asking you to do is to give one pair of supplementary angles, which we talked about previously. Okay. Supplementary. Excuse me. And one pair of vertical angles. So the way it's going to look is you're going to have supplementary angles. And it's going to tell you to type them in. And then it's going to say vertical angles. And you're going to type those in. All right. So for the supplementary angles, remember, they're going to be on a line. So you can pick any one of these 8 different pairs that are here. So it's on a straight line. So it could be 1 and 5 because they're on a straight line here, straight angle. It could be 2 and 6, 8. Or it could be 1 and 2 because they're still on a straight line here. 5 and 6 are also on a straight line. 3 and 4, and 7 and 8. So you got a whole myriad, big number of them. So I would just take, just me personally, I'm going to go 1 and 5. But you could have picked any one of those pairs I just said as supplementary. That's pretty easy. Then we're going to talk about vertical angles. So if you remember, vertical angles are not what they seem. They're not vertical from each other. They're not up and down from each other like vertical sounds like. What they're referring to here is, there's one here as well. What they're saying is they want the ones that are going to be on opposite sides across from the vertex. So for example, 1 and 6, or 5 and 8, or 7 and 4. Those are all pairs, okay? Any of those. Just about knowing what vertical angles really means. All right, we good with that? Jumping in the chat, let's go. This isn't science, but it's okay. All right. Oh, you're welcome, Ethan. I'm glad to do it. So does that help now with the vertical angles? That makes sense. Okay, good. All right. Am I still freezing? I thought I was doing pretty good. Oh, my voice is glitching out? Oh, no. Oh, no. It's the bots that are coming to get me. Okay. As long as you're good, now let's go ahead and move on. All right. Let's jump up to number 10. All right, we're almost there, guys. So number 10, again, we've got vertical angles here, which it can help us out. So remember this vertex right here in the middle? That's the vertex. That's what we're talking about with vertical angles. Now they gave us one of these four angles. They want us to find the other three. And the great part is with one piece of information, we can find all of them. So watch this. So we've got angle 4. They told us the measure of angle 4 is 51 degrees. So let's go ahead and label that first. This is 51 degrees. Remember, tomorrow on your test, you can actually just draw this on the whiteboard and start filling in the boxes. That'll help you, okay? All right, now if I know angle 4 is 51 degrees, using the property of vertical angles, I know that 2 has to be exactly the same as 51. And it kind of looks that way anyway. If I took this angle 4 and flipped it over across the vertex, it would be exactly the same as angle 2. So that one is also 51 degrees. So you get it, Alex, you're going to have these little boxes. You just type them in. I'm going to just fill them in on the chart here because it's easy. Okay? So we got 2 angles down already. Now we got to find 1 and 3. Now, if you find 1, you're going to instantly know the other because they're also vertical angles, right? Right. Now, I can look at either angle 1 and 4 because they're supplementary, meaning they're going to add to 180 degrees, or I can look at 2 and 3, or 4 and 3, or 1 and 2. They're all the same. That's the great part. So I'm just going to look at 1 and 4 just to make it easy. Now, these are supplementary angles because they're on a straight angle. Remember, this whole thing here has to add up to 180. So if I already know this was 51, all I have to do is take 180 and subtract 51 from it. Wow, that's a really terrible 5. Let's fix that. All right, 51. Now, when I do this, what am I left with? 129. So that's going to be 129 degrees. And again, since 1 and 3 are vertical, that is also going to be 129 degrees. And we're done. Just like that. How does that feel? Okay, so remember, supplementary angles are on any kind of straight line. It doesn't have to be up and down, left and right. Supplementary angles are always going to add it to 180. You want to go back to 9? I can do that in a minute. Supplementary, so yeah, does that make sense now? Kind of, sort of, I hope. All right. Okay, you're good? Okay. Do you need me to still go back to 9 or no? Yeah, supplementary, remember, they're just on a straight line. Okay. All right, so let's go ahead and go to 11. All right. Now we're looking at the internal values of angles. All right. So any triangle in any kind of formation, right triangle, acute triangle, obtuse triangle, isosceles triangle, all these other crazy triangle names, all of them, all their angles have to add up to 180 degrees, just like a straight angle. So they're going to add up to 180 degrees. All right. Because of that, we can find a third angle if we already know 2. Now, 1 angle is not going to help us enough, but 2 angles, we can always find the third. So in this triangle, they gave us 2 of them, and they want us to find the third angle. So what we have to do is take these 2 angles we already have, 106 and 35, add them up. Really, you got this plus x over here, right? And that's all going to add up to 180. So what I can do is I can add these together. This will be 141 plus that angle x equals 180. And I can subtract 141 from both sides. And I have x equal to 39. So that means this missing angle is 39 degrees. Is that all right? All right. Thanks, Rod. Thanks for logging in. All right. Okay, Ethan, what's up? Oh, you're still writing. Okay, good deal. No worries. Yeah, sometimes I go fast. So we got 3 more problems, guys. I hope everybody's feeling a little bit better about this. And if you need to go back into it, you can always just, again, just watch it over at the end. It's going to be posted on the channel. And if this is beneficial to you guys, I'll keep doing it every time we have a test. Okay, let's go ahead and move on to number 12. All right. So for this one, we're doing with these external angles of a triangle. But it's all the same properties we already know. We're just using it in a different way. So remember that all the angles inside of a triangle have to equal 180, right? But I said we had to have 2 angles in order to find a third. Right now, all I have is this 33 degrees here. And I got an X. I don't know what that is. So I can't find the missing one because I only have one. But I do have this weird 134 degrees hanging out here, right? So since it's on a straight line, I know that that angle plus the missing one I need for the triangle have to add up together to be 180 degrees. So if I take 180 and I subtract 134, that's going to leave me with 46, which means this angle inside the triangle is 46 degrees. Now I have 2, and I can find the missing angle. So again, I can go 33 plus 46 plus that X angle is going to equal to 180 degrees. If I add those together, I get 79 plus X equals 180. Then I can subtract 79. And I get X equal to 101. So X equals 101 degrees. All right, is that okay? Feel free to like the video, subscribe to the channel if you're not already on the channel, subscription. Click that little bell so you can get updates whenever I go live. Appreciate the hearts, love it. All right. I'm still freezing? Looks clear to me. All right. A little bit. Okay. Well, hopefully the good news is when I'm done recording, it'll be there ready for you. You can go back and watch it through, and we'll see if we can make that a little bit better next time. All right. Here we go on to the next one. Moving on to number 13. We got 2 questions left, guys. All right. Question 13. We're looking for X. Remember again that inside of a triangle, all the angles add up to 180 degrees. But I don't really have any angles in here. Nothing I can do to help myself out. I got this 95 hanging out outside the triangle. I've got this 38 degrees hanging out outside the triangle. But I can use some of the properties that we know to get some of the ones we need so I can find this X. This right here, remember what that's called? That's called the vertex, which means I have vertical angles here. So if this angle down here is 38, then I have this one that is also going to be 38 because vertical angles are always equal. Now, as far as this 95, remember this is on a straight line. So both of these angles together have to add up to 180. So if I take 180 and I subtract 95, that's going to leave me with 85. Sound right? Yeah, 85. So this is going to be 85 degrees inside here. So now I have two angles inside my triangle to find the x. So I have 38 plus the 85 plus x, which equals 180 degrees. If I add those together, I get 113. Yeah. And that equals 180. So if I subtract 113 from both sides, that's going to leave me with x, which equals to 67. So x equals 67 degrees. All right, how's that? Remember the key here always is if it's a struggle to kind of visualize everything, draw a picture, make it make sense. Yeah, I'm waiting. Go ahead. Go ahead and finish writing. Yeah, if you get, there's a few different pictures they'll put on this kind of question. If it's more complicated, it just means there's more steps. There's more different times that you're going to have to use the angle theory, meaning, the three angles inside a triangle will add up to 180 degrees, or supplementary the right triangle. Okay, so if you're struggling on the ones where you choose if it's a right angle triangle or not, all you have to do is put the three sides. You take the two smallest and the largest and put it into Pythagorean theorem. So the a squared plus b squared equals c squared. If you put all those numbers in and they are equal on both sides, then you know it's a right triangle. If it doesn't work, one's bigger than the other, then it's not. Does that help? Oh, no problem. We got one question left. All right, so one more to go. All right, question 14. All right, for this one's relatively easy. Any four-sided shape, rectangle, square, or even this weird trapezoid, okay? Any of these four-sided shapes, all the angles add up to 360 degrees, always. So all I have to do is take all these sides, all these angles, I should say, and add them up and subtract from 360. So we've got 91 plus 68 plus 67 plus x, and all that equals 360 degrees. Now, all we have to do then is add up those sides, and we'll get our answer. All right, so we have 91 plus 67 plus 68. So that gives me 226. So I've got 226 plus x equals 360 degrees. We subtract 226 from both sides, and we end up with x being equal to 134 degrees. All right. And that is it, my friends. That's okay. If you joined late, that's okay. It's still going to be there. It's going to be recorded on the channel. So just go ahead and go watch it again. And if there's any other questions, just message me on the channel. I'll be happy to, or put a comment down below, and I'll be happy to help out with that. All right. Other than that, You guys are going to do great tomorrow on the test. I'm really, really happy about that. I'm happy with so many people jumping in and really putting an effort in to do better on this test tomorrow. And we'll finish up this quarter on a good note. You're very welcome for all the help. And I'll see you guys tomorrow. Until then, keep the math mathing.